let's talk about this question. We are given that three blocks on a frictionless horizontal surface are in contact with each other. The force F is applied on mass A, so we have to draw the free body diagram of each block. So that's one. So let's do that. Do we have friction? No, we don't have any friction, so that's frictionless. So that's a good thing to hear. Let's talk about block A. So for block A, we have the weight of A, we have the reaction force of A due to the floor, and we have this force which is acting on A, and that there would be a reaction force, let's call it R1, between block A and block B. So this is for block A. Likewise, if we draw for block B, we definitely have a weight of B, we have a reaction of we have actually the reaction force, the upward reaction force is definitely going to be same for all, but okay, let's draw it and let's write it as FB. So at B, B has two contact surfaces, each of this. So A will exert a reaction force on B, which is R1 over here, and C will exert on B, which is R2, let's say over here. Likewise, we have it for C, wherein we have WC, we have the reaction force C, and we have just one force because the B will exert on C, which is R2. So R2 will act over here. So these are the free body diagrams of all the three blocks. The next part talks about, let's see, the acceleration of the system in terms of MA, MB, and MC. So this is pretty much easy because the F net is equal to mass, which is the net mass. So MA plus MB plus MC times acceleration. Because we are taking this complete system as a unit, so that can be assumed as a block which has a force acting with F, and the mass having MA plus MB plus MC. This can be assumed like it. So the new mass for the system is MA plus MB plus MC, which means that the acceleration is going to be force over MA plus MB plus MC. So this would be the required acceleration. Uh, Next, it talks about the net force which is acting on each block. The net force which is acting on each block. Okay. Uh, do we have to give in terms of MAMBMC, or I think yes. So what we can do is the net force acting on each block. Hmm. Uh, Over here, let's talk about block A. So for the block A, the net force is definitely going to be mass times acceleration, because if we talk about net force on A, let's call it FA. So that's going to be mass of A times acceleration. That's what we can do because they're moving at the same acceleration, right? And we already have the value of A. So their net force is going to be MAF over MA plus MB plus MC. Likewise, FB is going to be same as MB times A. So that's going to be MBF over MA plus MB plus MC. And likewise, FC is going to be equal to MC times A, which is MCF over MA plus MB plus MC. So these are the net forces on blocks A, B, and C. Let's talk about the next part. It has various parts. For the force of contact on each block that each block exerts on its neighbor. So we need to find the value of R1 and R2. So that would be pretty much easy now because we already got the net force. So let's talk about block A. For block A, the net force is F minus R1, and that's equal to FA, right? That's equal to FA, and FA is already we found that as it's equal to MAF over MA plus MB plus MC. If we rearrange this, then the value of R1 is F minus MAF over MA plus MB plus MC. And if we simplify this by taking the common denominator, we get F times MB plus MC over ma plus mb plus mc. So this is the reaction force 1. Likewise, let's do the same kind of stuff on block B. So R1 minus R2 is something which we have to write. So R1 minus R2 is FB, which is MBF over MA plus MB plus MC. Now, we already have the value of R1. So the value of R2 is going to be R1 minus MBF over MA plus MB plus MC. Let's write it as summation of M. So R1 is now F times MB plus MC over the summation of M minus MBF over summation of M. So if you're going to subtract this, the denominator is anyway common. So that's going to be equal to MC times, it's going to be MC times F over MA plus MB plus MC. That's going to be the value of the reaction force 2. And the last part talks about if all the masses are equal and that's equal to 10 kg, the force is given. We have to give the numerical answer for part B, C, and D. So all the masses are 10. So let's talk about part B first. So we're going to write part E. So we are going to find the acceleration now. The force is 96, and the force is 96, and the mass are 10 kg each. So the acceleration is F over the sum of all the mass. So that's going to be 96 over 30, which is going to be 96 over 30 is going to be 3.2. 3.2. This is the value of A. And then we have to find the reaction forces. So that is the acceleration times individual masses. So that's going to be same for all. So F net on A is going to be 32, and this is same as F net of B and F net of C. And then we need to find the value of R1 and R2. So for R1, that's going to be acceleration times mb plus mc. It means that 3.2 times 20, so that's going to be 64, and the value of r2 is going to be just 32, because as per the calculation is coming as 32 newtons. So these are the final numerical answers. Thank you.